I want to derive the distance formula. Let's think about these 2 points. I want to find the distance between the point at x1, y1 right here and the point at x2, y2 right here. And so we can visualize that straight line distance that I'm trying to find. And more specifically, I want to be able to apply that to any point. So what I'm going to do is just add in some information to help us out because I see a right triangle. I want to know this distance d, and I claim I can actually talk about these straight line distances, a horizontal distance and a vertical distance, a little more easily. Because what I realize is this horizontal length is just the difference in the 2 x-coordinates. Now the way I've drawn this picture, this would just be x2 minus x1, but I'm going to include that in absolute value just in case I don't really know which point has a larger x-coordinate, right? They might be plotted like this. In the vertical direction, I can think the same way, and this side would be the difference in the 2 y-coordinates, y2 minus y1, and again, I'm going to put them in absolute value so I don't have to worry about which one's actually larger. Well, now I have 3 sides of a right triangle labeled, and I know the Pythagorean Theorem applies. D squared is equal to this side length, x2 minus x1 squared, plus y2 minus y1 squared, still an absolute value. But here I realize that I don't need the absolute value because I'm squaring things. x2 minus x1 is either positive or negative, and when I square a positive, I get a positive. When I square a negative, I get a negative, so I don't really care which it is. And the same thing for y2 minus y1. So I just have d squared equals x squared minus x1 plus y2 minus y1 squared. If I take a square root, then I've derived our distance formula. This formula will find the distance between any pair of points in the plane. So the distance between points x1, y1 and x2, y2 is the square root of x2 minus x1 squared plus y2 minus y1 squared. And now we can do these 2 examples where we're just asked to find the distances between 2 different pairs of points. Here in the first one, well, let's see, I have x2 minus x1, so I have 5 minus a minus 1 plus y minus y, so 4 minus 3. And if I think about it, this is really a 6 squared plus a 1 squared. So that's 36 plus 1 is 37, and I get the square root of 37, a number that's just a little bit larger than 6. In the next one, I have d equals the square root of, I need to take the difference in 2 x values. I have minus 1 minus 2, well that would be minus 3 all squared, plus minus 4 minus 8, that would be minus 12 all squared. When I square a negative, I get a positive, so that's a 9, plus 144. That is equal to the square root of 153, and it turns out that's 9 times 17. And I always want to simplify under a radical, so my final answer here will be 3 times the square root of 17. And there's that exact distance. Unless we're told around, we always want to give an exact distance. So this one works out to be 3 root 17. Our distance formula will help us find the distance between any pair of points. And then we have 2 nice, happy examples here.